This is the video for text analytics, and in this section I would like to discuss about text classification. So the discussion in this video will be related to what is the prediction. Okay, so there are some types of prediction, and we are going to learn the definition of text classification, and there are some text classification use cases, and we are going to look at the variants of the classification, and also we are going to learn about the algorithms. Yeah. So let's start with the first about the prediction. When we deal with the text analytics, you will already learn anything is about prediction. We are going to predict something ahead from the current text. So there are two types of prediction. We call it unconditioned prediction, and the other is conditioned prediction. For the unconditioned prediction, we call it, this is to predict the probability of a single variable, or we can say it is the P of X. X is a single variable. So there are some variants that we are going to look at. The first is left to right auto-regressive prediction, left to right markov chain. Let's assume we use the order n-1. And we can also learn at the section about independent prediction and bidirectional prediction. The other type of prediction, we call it conditioned prediction. It is to predict the probability of an output variable given an input. So this is the output and this is the input. In the condition prediction, there are some types as well. For example, the auto-regressive condition prediction. And we are also going to know about the non-auto-regressive condition prediction. Now, let's take a look one by one. The first type of the unconditioned prediction, we call it auto-regressive model. So the auto is separate word with the regressive. We call it these auto-regressive models. It will generate the text by predicting the next word, or we call it token, in a sequence based on the words that have come before it. So if you look at this figure, okay, so the black color is the current word, and we are going to predict the red color, the red color, the red color, and so on. So it is in a step-by-step manner where each prediction depends on the prior outputs. So the mechanism is left to right, because we know that English and also Korean language, it is a language which is left to right. But there are some other languages, for example, the Arabic, okay, or the Greece, so they start from right to left. If we are dealing with the right to left, then there will be some other ways to handle those one. So let's look at the left to right auto-regressive prediction. In this case, we are going to multiply. So this is the multiplication of the probability xi given the previous words. So this is the x1 until xi minus 1. So there are some model, or there are some classifiers like RNN or transformer LM. They use this auto-regressive prediction. So the idea for this unconditioned prediction can be something like this one. I have an input, okay, for example, the cat sat on the something, something, something. So we are going to predict this one. So what will be the best word for this one? In the step one, okay, based on the input, the model might predict mat as the next word. Okay, so this prediction can be anything actually. So it is based on the model, or it is based on the, yeah, it can be based on the pre-trained model. Okay, it can be based on the current model, and etc. So the highest probability will be the uh, possible word for this one. Okay. And then after I have this sentences, so it will be considered as the next input. So after generating mat, the input becomes the full sentence, the cat sat on the mat, and then there is a blank. So we're going to predict again what will be the best one for this blank. So we are going to do another prediction. Yes. So the step 2, if we want to continue generating text, then the model predicts the next word based on the full sentence, and perhaps something like N. Okay. So the word N can be here. So the cat sat on the mat, N. Okay. And yeah, we can continue to predict the next word. The step 3, the step 4, step 5, and so on. Okay. So it will be repeated until it reaches the desired length or encounters a stopping condition. Okay. So it will be continuously until the end of text, or yeah, until one kind of condition. There is another type of prediction, we call it the Markov chain. So the Markov chain, it is a stochastic model that predicts the next state, or we can also use the next word based solely on the current state. So without considering the previous states. So the text, yeah, it is something related with the uh, previous states, and yeah, we will check the probability. Okay? The model generate text based on the probability of word occurring after the current word instead of the entire sequence. So if you look at this figure, okay, so the red color, it can be predicted by the black one. So the red color can be predicted by the black one. The red color predicted by black one. The red color predicted by the black one, and so on. So it means we just rely on two previous words. Okay? So two previous words, and so on. So we call this is the first order Markov chain. If it is first order Markov chain, then it is equivalent to the bigram. If it is second order Markov chain, it is equivalent to the trigram, and so on. Okay. And also we can use the 4 gram, 5 gram, but it will be more complicated if you apply with more n. Let's say, we have this corpus. Okay, we call it, this is the corpus. The cat sat on the mat. The dog sat on the mat. Okay. So let's say if I have this corpus and I want to use the Markov chain, you already know how to make this table. Okay, so this table, let's assume that we have the first sentence mark. Okay, so this is the beginning of the sentence. So after the beginning of the sentence, we have the, oh, actually this is, there are two. Okay, after the beginning of the sentence, okay, I need to fix this one. So the, and we have cat. Okay, so we have one, and then after the follows by dog. Okay, so this is actually this two, and then we have cat. Okay, cat, and followed by set, dog, followed by set, and so on. Yeah. Then, well, if we want to predict, okay, based on this transition matrix, let's say I have the word the, then what will be the next possible word? So we can go to cat or dog because the probability if we go to cat is 0.5, and if we use dog, then the probability is 0.5. So any word will be fine because the probability is the same. If the word is cat, then we go to set because set has the probability 1. And then set, if we have the word set, then we can go to on because the probability of on is 1, and so on. Okay. So based on this probability, we can assign what will be the best possible word. There's another type of unconditioned prediction. We call it independent prediction. So in the independent prediction, it refers to a model's ability to predict its token in a sequence without considering the context provided by preceding tokens. Okay. So this prediction is made based solely on the characteristic of the token being predicted, often using the statistical method or feature extracted from the data rather than any sequential relationship. So usually we don't consider the sequential relationship, we just consider the probability of that word. So some use case, it is to predict the uh, language which is missing. Okay. So mass language modeling or predicting the missing words in a sentence, and text classification, and also question answering. So the idea of the formula is something like this one. We just use only the unigram. So we want to know if this is the missing word or this is the location, then what will be the best word to represent in this location. Let's say I have the same word like what I explained before. The corpus is the cat set on the mat, the dog set on the log, and the vocabulary means the word that we have in the corpus is cat, dog, mat, log, set, on, and the. And for this one, we want to predict. Okay. So we want to predict based on the unigram. The unigram means one word. So in this case, let's assume that we already lower. Okay. Lower means we already changed the uppercase to lowercase. So there are 4 there. And then cat, okay, there is 1. Dog, there is 1. Set, okay, there are 2 on the corpus. On, there are 2 on the corpus. Mat, there is 1. Like log, we have 1. So we can have the probability distribution from this one. So when we predict the next word, we can simply sample from this probability distribution. So there are 40% of the, okay, there are 20% of set. Okay. So we don't care what will be the preceding words, okay, but we just care about the highest probability. Okay. So the high probability is this one and this one, this one. So if we need to do wording, then there might be some high possibility that the text is not that correct. Okay. But yeah, we call this is the independent prediction, and it can be used for the prediction in the text analytics. The common approach, we call it bi-directional prediction. So in the bi-directional prediction, it involves using context from both the left and right sides of a target token in a sequence to make prediction. So this approach allows the model to capture dependency from both directions. So it means we can see from the left and from the right. Okay. It enhances its understanding of the context and improve the quality of prediction. So some use cases, we can use the BERT, okay, so the master language model like BERT, and we can also have the fill in the blank, and we can also use it for semantic understanding. So some examples on this one is you can predict a missing word. in the missing word means I have a sentence, okay? So we can predict a missing word in a sentence. I have a sentence, and we can train the model like we provide the sentence with missing word and replace by spatial mask like this one. So the cat sat on the something blank and look at the dog. Okay. So in the bi-directional context, okay, so the model looks at the entire sentence. So this is the entire sentence and use both left, because this is the left part. Okay, so this is the left part and the right context. So this is the right context. Yeah, this is the right context. And we are going to predict the word. We are going to predict what will be the best for this word. Okay. So the possible prediction, maybe if we say it is probably math, because it will be about noun and it will be about a place or something like that one. So we call this is the bi-directional prediction. And yeah, the probability, we can use something like this one with the bi-directional prediction. So we are going to learn more about this one in some weeks later. For the condition prediction, so we also have auto-regressive prediction. So the idea is similar with the previous one that we already looked at. The model generates each token, word or character in a sequence, and it is influenced or guided by external input or context. So the external context create the condition for the model prediction. So for example, if we have the output, so the output will be something that we want to predict. So, and there will be some external context, or there are some external variable that will be used to do the prediction. It means the output depends on both what was generated previously, so what has been generated here, and some additional information provided. So there might be some additional things. For example, if I want to know the y given x, then y is something that we want to predict, and then we have x is another variable, or something related to the context, and also with the information about the text or the sequence. So for example, the model can be used in the sequence to sequence model. Usually we use this one as a prompt. Okay. And if you know with the current GPT approach, so this is one of the example with the text generation with prompt. So the model generates the next part of a story based on the input prompt. So for example, the prompt, well, we put like this one. Once upon a time, there were three little pigs. Three little pigs. Samyongbaji. Yeah, I'm not sure what is the Korean, but yeah, it is a story about the three little pigs. And because we know about this kind of story, so the text or the model is conditioned based on the prompt. So it predicts the next word based on it. For example, it predicts who. Okay, we can know that this is noun, then maybe the next is who. Okay. And based on once upon a time, there were three little pigs who, so we can have some idea what will be the next word. Okay. For example, we want to predict it as will. So the model continues predicting words until it completes the sentence. So because we know that this is the context, three little pigs, and this is another context that is about a story in the previous days, then we can make a sentence like once upon a time there were three little pigs who built houses to protect themselves from the wolf. We can also use the auto-regressive like this one to translate. Okay, so the machine translation from English to Korean. Okay. So suppose there is a sentence, I love eating apples. So the model is conditioned on the input English sentence. And yeah, if we want to translate from English to Korean, then we can understand that first, the model looks at the input I. Okay, I know I, it refers to a subject, and this will be related with the Korean translation nanan. And then the step two, it looks at love. Okay, because the word love is the second one, but it predicts sagwa, rel. Okay. Why? Because in Korean, the object comes before the verb. So it can be predicted for the next, which is Moknan Kosel Joayo. So the full translation will be, first we will do the nanan for I, and then sa for the next at Moknan Kosel Joayo. It is the last prediction. Okay. So this is an example about the auto-regressive prediction. For the non-auto-regressive prediction, the model generates all the token at once, so word, phrase, simultaneously, rather than generating them one by one as in auto-regressive. So the idea is only just whether it is step by step or it is generating them at once. For example, you can see here, given x, we want to predict y at this position. We want to predict y at this position. Okay, but it is different with the regressive, which is considering some of the sequence in the previous text. Okay, so this is the sum of the sequence in the previous text. So the auto-regressive and non-auto-regressive, what is the difference? If we look at the difference, it is like writing a sentence word by word. So you start with the first word and then move to the second and keep going until the sentence is complete. For non-autoregressive, it's like typing an entire sentence all at once. So yeah, you can just put everything at once. Okay? So you don't need to go word by word, and the system instantly gives you the entire sentence. Yeah, maybe it is difficult to clearly understand this one. So later on, we will learn one by one. Maybe not all of them, but yeah, at least you can know what is the meaning by this autoregressive, non-autoregressive, and etc. Now we are going to focus on the text classification. Yeah. So the prediction, it is one of the key in the text analytics, and also it belongs to the classification part. Yeah. What I mean by belong to the classification part means that when the text classification, it is a method to organize the text into one or several predefined categories. So I have, for example, X, yeah, I have the information, I have the features, and I want to know what would be the best categories for that text. Okay. Some other terminologies, we call it as the text categorization or document categorization or document classification. Some use case for this text classification is like the spam classifier. Yeah. And if you use Gmail or if you use any email service, I think you may have these things. So some emails might be spam. Okay? Spam is email that is not related to ours, but it enters our inbox. Okay? So the spam email and any email, yeah, it can be classify into whether it is a primary email or whether it is a spam email. So the document classification from the academia. So if you look at non-moon. Okay, so there are many research paper. If you have a research paper, then we can look at maybe for the keywords. And there are many common words. So what are the common words in the paper and so on. And after we know all those things, we can classify whether this belongs to health, or this belongs to life science, or this belongs to physical science, or this belongs to social science. So we can classify it based on the commonness of the words. Or maybe we can look at the social listening. What does it mean by social listening? If we have the word from the social media or the review, if we have the review, then we can classify whether it is a complaint, or whether it is a product question, whether it is competitors, yeah, or it is about the content performance, or it is about requests. And we can also do with the categorizing the support tickets. So these tickets is not the tickets like you, is not the Kumyon ticket, the ticket performance like in the I don't know, like concert, or like maybe the performance in the theater. Okay, so this is not that one. Okay, so this ticket is for the ticket usually you use for the software engineer, or maybe it is something related with the complaint application, or yeah, inquiry application, something. So once you apply something, then there will be a ticket. Okay. And usually we can put our text. What is your question? What is, you know, or maybe what is your inquiry? Okay. And then after you put the text, then the text can be classified whether it is about billing, maybe someone want to ask about the billing, or they want to give feedback, or maybe it is about question, or it is a complaint. Yeah. And yeah, as we know, we can also do this as the sentiment analysis. So we learn whether the text can be classified into positive or neutral or negative. So yeah, we already learned a little bit about the language modeling, and we can use this as the classification, or the binary classification. And the binary classification means I can classify whether this word belongs to positive or negative. Okay, because there is a word hit, then okay, this might be negative. Okay. Or we can also use the multiple classes or multi-class classification. If I have this word, I hate this movie, because the word hate is very, very strong. Okay. So because it is very strong, then we can categorize it as very bad. Okay. Maybe some other word is not that strong in the text, so maybe it is neutral. Okay. Or we can also have some category in between very good and neutral, very bad and neutral, which is bad and good. So it is just the middle between the two, the middle between the two. Or if we have our text, for example, the Korean economic increase, then we can make the category, okay, this might the best belong to economic rather than finance or sport or international or entertainment. So this is the category in the news. Okay. Then we can have any kind of category to represent this one. Yeah, as we already learned before, we also can do the classification based on the structure. Okay, so we call it a structure prediction. Okay. So the word prediction, there are a lot of terminologies that we can apply. Okay. For example, in this case, we have the exponential or infinite labels. Like I hate this movie, so I can put this as the preposition, verb, okay, and determinant and noun. If we want to do the machine translation, yeah, we can do something like this. If we want to do the machine translation from English to Korean, then we can have like this one. Okay, so the idea of the text classification, we can have a structure prediction, and after we have the structure, we can translate into some other languages. So the text classification actually, yeah, we have an input. So what we already learned previously, we always look at what is the input. So the X is an input, and if we have the input, so we will extract the features. So what are the features that we will use? Okay. So for example, this is the feature extractor for the word I like pages. And we want to predict the label Y. The label Y means, yeah, for example, I have this, yeah, maybe this is the representation after the feature extraction. Okay, I can predict that it is positive. The positive means this is the sentiment. We can also use some kind of like sequence labeling. So this is also another type of text classification. For example, I have the I like pages. So based on the feature extractor, we have feature representation here. Okay, so I have the feature representation for I have the feature representation for like, I have the feature representation for pages, and then I can predict. Okay, I can predict. And okay, this belongs to pronoun, this belongs to verb, and this belongs to noun. And yeah, we can see that this is the sequence in our text. If we know that this is the sequence of the text, then we can generate what will be the best next word or what will be the best next sentences. Yeah. So this kind of text classification, yeah, we already know some basic idea, and yeah, we're going to learn about the algorithm. I will stop this video and I will continue with another video to discuss about the algorithm.